let's go ahead and look at our first periodic trigonometric function, the sine function. Here's the basic equation. We usually see a theta, a Greek letter, when we talk radian measures, and we usually see an X or an alphabetical number or letter when we're talking about degrees. So the theta here says we're going to be dealing with radians. Now the sine function, if you take out your unit circle and you start at 0 degrees and you start looking at sine values, you're going to see as I move through the first quadrant, they get bigger and they max out at 1. And then they start getting smaller and they bottom out at -1, and then they get back to 0 again. Well, what I have graphed here is those exact same values. And I'm going to pick out a couple of key ones. So at 0 degrees, the sine value is 0. When you get to pi over 2, which is 90 degrees, it maxes out at 1, comes back to 0 at pi, which is 180 degrees. Then it starts going negative. We're down in that third quadrant. And we bottom out at -1 at 270 degrees, 3 pi over 2. And as we finish this circle and we get back to our starting point, 2 pi, all the way around the circle, we're back to 0 again. We never went above 1. We never went below -1. That would be our amplitude. And this thing starts repeating after 2 pi, so that would be our period. That's where these two numbers come from. A couple other key pieces. Everywhere it crosses the x-axis here, those are the zeros. And I've got a maximum here at pi over 2, and I've got a minimum here at 3 pi over 2. So this is the basic sine curve. This is where we're going to work from. As we start talking about it more and more, we're going to make changes to the sine curve. This has all of them. We're going to focus in on 2 of them in today's lesson, but this does have all of them. So when we put that number in front, whether it's positive, whether it's negative, that is our amplitude. Notice we take the sign out. We're going to explore what happens when I put a negative in there in one of our examples today. The b, which is after the sign but before the angle, has to do with period. A normal period for sine is 2 pi. It takes 1 full revolution on your unit circle, which is 2 pi. But if there is a number sitting here, it's going to change that period. Now the 2 we won't get to today, but I wanted to talk about them, are these 2, my h and my k. K is what we call a vertical shift. It moves the whole graph up or the whole graph down. H is what we call a phase shift. We move it left and right. That's what those 2 are going to do. We won't see much of that today, but we will as we continue on with these trig functions. So let's take a look at one of these. And we're going to attack this a little differently than you might see in textbooks. In textbooks, what they're going to do is they're going to take this number and they're going to show you what the graph would look like with that change. What we're going to do is we're going to take a normal sine curve and we're going to make change to our scale. Now there's nothing in front, so this still has the same amplitude of -1. That's what's normal for the sine curve. But what did change is this number right here. Normally, this value right here would be 2 pi. But with the number that's sitting here, and I reduce, this number is now pi over 2. So that means we actually shortened this sine curve. Bigger number, we shorten it. Smaller number, we'd actually lengthen it. So if you actually looked at this graph on a normal axis, it would go up and down and back in half the time. We're going to change our scale, which means halfway is now pi over 4. The in-betweens would be pi over 8 and 3 pi over 8. This shows that the period has changed. It's now pi over 2. So we're going to have all of our graphs for sine look the same. So even in this one, we're going to take the sine curve like it normally would look, and we're going to make adjustments to our scales to correspond to what's going on. Now in this example, there's a number in front, and the number in front has to do with amplitude. So now it goes up 2 and down 2. So if you think of what a normal sine curve looks like, and you think about something that has bigger amplitude, it would actually look like somebody pulled on it. We're not going to make a change to the graph. For our purposes, we're going to keep it as a sine curve, but we're going to change our scale over here. Now, since there's no number here, our period is normal. So this is 2 pi, this is 1 pi, we've got half a pi here, and 3/2 of a pi there. Those numbers didn't change because there was nothing here to affect the period. Now, this one, they want me to change both. So I'm going to start with the graph. They want an amplitude of 3. So here's my sine curve. My amplitude of 3 means I go up 3, I go down 3, all starting from 0. And they want my period to be pi. Something like that. Now, to bare minimum, this is what I'm looking for in a graph. A lot of people will put the in-betweens in. It's just a matter of doing your fractions. But now I want an equation to kind of show where this came from. Okay, and sometimes this can be difficult. So we know it's a sine curve. And we know that we changed the amplitude. So we're going to put that number in front. That's where that 3 goes. But now we have to figure out what's going on right here. Now normally, period for sine is 2 pi. It starts repeating. It starts cycling after 2 pi. But we have a period of pi. So I got to figure out what they divided by to make this work. So I'm going to cross multiply to get rid of my ratio here. And if I divide by pi, it looks like b has to be 2. So if I put a 2 in here, that's going to shorten up my period to match my graph, and my period's going to become pi. Now, they're not going to tell you what they're changing. You're going to have to figure that out on your own. So here's another example. They just kind of gave you the equation, and you're supposed to graph it. Remember, we're not going to change the graphs. This is a sine curve. It should look like a sine curve. We're going to change the scale. Amplitude of 3, and the period definitely changed. It's 8. Normal period is 2 pi, but I have to divide by 8. It looks like my new period is pi over 4. Bare minimum, that's what I should have on there. If I want to catch the maximum and the minimum, I can do that as well. One that I did not put up here is I never put one with a fraction. But imagine if this would have been 1/8. So when I divide that by 1/8, I would actually get 16 pi. So that means all the way out here would be 16 pi. I have stretched this thing and made the period longer. Halfway would be 8 pi, 4 pi, 12 pi. It kind of works backwards. Bigger numbers make the period shorter. Smaller numbers make the period bigger. The last thing I want to look at is what would happen if this same example was done, but with a negative in front. Now, it's not going to change the amplitude, and it's not going to change the period. But what this negative does is it actually changes which direction my sine curve goes first. Instead of going up first because it's positive, I'm going to go down first because it's negative. Nothing else changes except the direction we go first with our sine curve. Now, as we dig into these trigonometric functions a little more, we'll talk more about the phase shift and the vertical shift, but our next step is going to be talking about cosine and then finally tangent.